dozens of hatched and unhatched eggs have been discovered in Florida's Big Cypress National Preserve.
For years, the Everglades seemed resigned to silence, a wilderness slowly emptied by an invader that hunted without challenge or consequence. Yet beneath the still water, something subtle began to shift, as if the landscape itself were preparing a reply, and the first hint of that awakening arrived not with a roar, but with a single disappearing clutch of eggs. The quiet collapse of the Everglades. Before anyone recognized the scale of the unfolding disaster, the Everglades had already begun to change in ways that were almost impossible to reverse. Because the Burmese python did not conquer the landscape through sudden force, but through a gradual, almost invisible infiltration that reshaped the food web from the bottom up. The snake arrived through the exotic pet trade, entered the wetlands unnoticed, and expanded into an apex predator with no natural opposition capable of containing its growth, allowing it to erase entire species before biologists fully understood what was happening. Mid-sized mammals, once common along tree lines and marsh edges, vanished as if erased from the ecosystem, leaving behind a silence that felt unnatural in a place defined by constant movement and sound. Researchers later described this phase as an ecological collapse driven by naive prey syndrome, a condition in which native species had no evolutionary memory of such a predator and therefore showed neither avoidance nor defensive behavior. The python's hunting method, guided by scent, thermal detection, and rapid ambush, exploited that vulnerability with brutal efficiency, transforming the Everglades into a system where prey disappeared faster than the landscape could replenish it. As this decline deepened, early conservation efforts proved insufficient because humans could rarely locate the snakes that were dismantling the ecosystem from within. Yet even in this period of apparent defeat, the first subtle signs of change were beginning to take shape, suggesting that the Everglades was not simply collapsing, but preparing to respond. Tracking the enemy. When field teams finally acknowledged that traditional removal efforts were failing, they realized the problem was not rooted in a lack of effort, but in the overwhelming advantage the python possessed within this vast, waterlogged terrain. Because a predator that rarely moves in daylight and often buries itself beneath dense vegetation cannot be hunted by eyesight or intuition alone. Biologists needed a method that would allow the snakes to reveal their own locations, which led to a strategy that felt more like intelligence gathering than wildlife management. They captured large male pythons during the breeding season, implanted them with radio transmitters, and released them back into the swamp with the expectation that these individuals would, by instinct, travel directly toward reproductive hotspots hidden deep within remote marshes. The plan worked with remarkable efficiency because each tagged male became a guide that led researchers toward clusters of breeding females, individuals that were otherwise nearly impossible to locate by human search teams. Yet for scientists like Andrea Curlow and her colleagues, finding the snakes themselves was only the first step in a longer mission, since the true objective involved identifying the nests that sustain the python population's explosive growth. Python eggs, well insulated by vegetation and guarded by fiercely protective mothers, represent the most critical point in the reproductive cycle, meaning that access to those nests could finally provide a way to disrupt the invader's dominance. In June 2021, one of these tagged males led researchers to a concealed chamber in Big Cypress National Preserve, where a massive female lay coiled tightly over her clutch. Cameras were installed, and the team withdrew, expecting routine nest guarding behavior. Yet the footage that followed revealed something far more consequential for the future of the Everglades. A native predator rewrites the story. The camera footage at first appeared uneventful, showing the female python maintaining a constant vigil over her eggs, because successful incubation depends on her ability to regulate their temperature through subtle muscular shivers that keep the developing embryos warm despite the fluctuating conditions around the nest. However, on a late afternoon when the heat became critical to her own survival, the mother briefly left to drink and recharge, creating the narrowest possible window during which the entire reproductive effort stood unprotected. What happened next was not an accident of timing, but the emergence of a new behavioral script within the ecosystem. A male bobcat entered the frame with deliberate caution, pausing repeatedly to assess the scent trail that marked the python's departure, suggesting an understanding that danger was present but not immediate. The animal investigated the clutch, tested the leathery shells with exploratory bites, and then committed fully, piercing and consuming the eggs with a precision that indicated this was not a random experiment, but a newly learned technique. More surprising still, the bobcat removed several eggs and cached them nearby, treating the python nest not as a threat, but as a predictable food resource that could be revisited. When the python returned, a confrontation followed that challenged long-held assumptions about predator hierarchies in the Everglades, because the bobcat did not flee immediately, but engaged defensively, dodging strikes and retreating only after asserting its willingness to resist. Scientists reviewing the footage recognized this moment as the first documented instance of a native predator dismantling a python nest, marking a turning point in the invasion narrative. This encounter demonstrated that the Everglades was no longer a passive victim, and these newly emerging behaviors hinted at a broader shift that extended well beyond one daring bobcat. The wider resistance emerges. As researchers expanded their monitoring efforts across the Everglades, they began encountering additional evidence that the bobcat's bold raid was not an isolated anomaly, but part of a growing pattern of native species, redefining their relationship with the invader. Telemetry studies on python hatchlings revealed an unexpectedly high mortality rate, and when the signals of tagged young snakes went silent, investigators traced the locations, only to discover that the transmitters were still functioning, now lodged inside the bodies of Florida cottonmouths. The vipers had consumed the hatchlings before they reached a size that would have made them untouchable, demonstrating that these native predators were exploiting the python's most vulnerable life stage with increasing frequency. Further south, a separate field team uncovered the partially buried remains of a juvenile python, whose injuries suggested deliberate killing rather than scavenging, and when a camera trap was placed at the site, it documented a bobcat returning repeatedly to feed on the carcass. The implication was unmistakable. Everglades predators were no longer responding with fear or avoidance, but with assertive, opportunistic predation. Even species that once appeared paralyzed by the unfamiliarity of the python's scent were now investigating that scent as a potential resource. Human strategies began shifting as well, because biologists recognized that the most effective way to reach hidden snakes might be through the behavior of the animals the pythons targeted. By placing GPS collars on raccoons and opossums, researchers could trace the moment a python consumed one of these prey animals, effectively transforming the victim into a beacon that guided removal teams directly to the predator. These developments revealed an ecosystem beginning to coordinate its resistance, setting the stage for an even more profound evolutionary contest. Evolution in real time. When biologists examined these scattered encounters together, they recognized that the Everglades was demonstrating a form of rapid adaptation usually associated with long evolutionary timelines rather than the span of a single human generation, because native predators were not only altering their diets, but adjusting their behavior in ways that reflected problem-solving, risk assessment, and the refinement of newly learned techniques. This shift echoed patterns observed in other ecosystems facing invasive species, such as the Australian crows that learned to avoid the toxin-laden organs of cane toads by flipping them over and feeding selectively, or the predators in Southeast Asia that eventually adapted to the arrival of unfamiliar prey species. However, the speed at which the Everglades was responding suggested that something even more dynamic was underway. As scientists documented the behavioral changes among native mammals and reptiles, they also observed emerging adaptations within the python population itself. Field teams in South Florida began encountering clusters of nests located unusually close to one another, with multiple females depositing their eggs in the same sheltered areas and occasionally remaining near adjacent clutches in overlapping defensive positions. Although rare in their native range, this communal nesting behavior appeared to provide strategic advantages in the Everglades because it concentrated the reproductive effort, increased the likelihood that at least one female would remain on guard, and complicated the efforts of predators attempting to raid the nests. This development hinted at a deeper evolutionary tension, because every successful raid by a bobcat or cottonmouth removed the most vulnerable breeders from the gene pool, leaving behind snakes that either defended more aggressively or adopted nesting strategies that reduced exposure. The invasion was no longer defined by one-sided dominance, but by a feedback loop in which each adaptation provoked a countermeasure. As these patterns intensified, researchers began to understand that the struggle between predator and invader was becoming a long-term, ever-evolving contest that would shape the future identity of the Everglades.
A new Everglades takes shape.
As scientists traced the accumulating evidence, they realized the Everglades was not drifting toward restoration, but toward the emergence of an entirely new ecological balance, because the decades-long invasion had altered the foundations of the food web so profoundly that returning to a pre-python state was no longer biologically feasible. Instead, the landscape was evolving into a system defined by constant negotiation between native predators learning to exploit the python, and pythons adjusting their strategies in response to mounting pressures from their surroundings. This shift reflected a broader ecological truth. Resilience is not the reappearance of what once existed, but the capacity of an ecosystem to reorganize itself under stress while maintaining the functions that allow life to persist. Within this transforming environment, species once considered passive victims were becoming dynamic participants in a new predator hierarchy, and their willingness to adapt suggested an Everglades shaped as much by behavioral innovation as by raw survival instinct. Researchers now view this landscape not as a battleground destined for ruin, but as a living laboratory that reveals how quickly nature can reconfigure itself when forced into conflict. The Everglades may never return to the world it once was, yet in the struggle between a relentless invader and the wildlife learning to confront it, a new wilderness is taking shape. If this story moves you, subscribe and stay curious, because the next chapter of nature's resilience is already unfolding.